right, we're going to take a look at section 3.3. And so section 3.1, I talked about this before, but we'll do it one more time here. Section 3.1 was about addition and subtraction, and it was the conceptual ideas of the kinds of models we have for addition and subtraction. And then in section 3.2, we talked about algorithms, which is ways of actually doing the addition and subtraction, different methods for actually doing the processing of it. Section 3.3 is again back to the conceptual ideas of multiplication and division, the different models, why we would multiply, why we would divide. And then 3.4 is going to be, again, the algorithms, the ways in which we do that. And we'll get to 3.4 after the break. But 3.3, we're going to start with what multiplication actually is. So if we have whole numbers a and b, and n is not 0, then if we have a plus a bunch of times, so one way to add something together a whole bunch of times is to actually use multiplication. Okay, repeated addition is what multiplication is for. So, my goodness, that was unexpected. Let's try it again. Okay, so there's n of these guys here. Then, whoops, not there. Yeah, that'll work. I didn't have it there in my notes, but that'll work. And this is n times a. Okay? N times a. So there a bunch of times. And if n is equal to 0, then we define that 0 times the number a is equal to 0. It's just a definition. Because it doesn't really make sense to talk about something occurring 0 times. Something would be kind of an awkward statement, so we'll talk about it as being a definition. All right, so for finite sets, if you have a capital A set and a capital B set, and you talk about the fact that the number of items in set A is A, and the number of items in set B is B, then we encountered this idea of a Cartesian product. And when we did so, we talked about a formula for that. We said when we did the Cartesian product, two different sets, that the way that we found out how this worked was that this was actually the number of items in A times the number of items in B. And if we're calling the number of items in A little a, then this is little a. And the number of items in big B, little b, then this is b. So this is our definition for multiplication of two numbers a and b. All right, let me talk about the models of multiplication, because this is where things get a little more interesting. Ready? All right. One model for multiplication is repeated addition. This is actually how we define multiplication. For example, Jessica takes 3 tests every Friday. After 4 Fridays, how many tests has she taken? Okay. So the idea is, of course, if we were to do the problem out, we would have 3 4 times. So this is 3 times 4, which is 12. Okay. All multiplication is really is it's shorthand for addition a bunch of times. Okay, and that's how you introduce it to multiplication. You just don't want to have to add something together a whole bunch of times to multiply. We know these multiplication types. All right, an array model, and I'll draw you a picture of this one. This one has a good picture to go along with it. Is used for sets as well. Marty is baking cookies. He's able to place the dough 3 cookies wide, 6 cookies long on his pan. How many cookies will his pan hold? You can picture this, right? Okay, we've all made something like this maybe before. And let's do a circle for it. So he's supposed to make 3 wide, right? Infinite Cloner allows you to clone something as many times as you want. If you click on clone, it clones it one time only, kind of like a copy paste. What I did there was I did 3 of the items and I wanted them to all be grouped together. So I went underneath grouping and I told it to group them. And I can ungroup them the same way. But it allowed me to do the Infinite Cloner with it in a straight line. They were actually lined up instead of it having to be lined up by me or just flat out not in a line. Okay, did I get them all? Okay, so you've got the image right of the cookie balls, cookie dough balls. We assume he didn't eat all the cookie dough. Apparently. All right, so if we have this, how many cookies will this pan hold? So there's 6 here, 3 here, and 6 times 3 is 18. And you can count up the 18 there, of course, as well. This is the picture that follows with the group, this idea of an array. You know, this is different than the first one, right? I mean, the process for doing this is a very different conceptual idea. The first idea is repeatedly adding a bunch of numbers together. This one has a much more concrete picture form to it. As does the next one. All right, so the next one has some similarities to the array model. It's called the area model. And the area model is used for measurement, okay? So what do I mean by that? Well, do you remember when we were back in section 1, we had a number line model? And I told you that even though we were working in whole numbers, the number line model really only made sense if you were talking about something that could be, say, for instance, a half of something. And so I wouldn't use a number line model for counting the children in my classroom. But using a number line model for counting the number of feet long the classroom is, that makes sense. Because it's a distance that could be measured in a way that was fractional. Same thing here. An area model is the same kind of model, same kind of picture as an array picture, but it uses things that are actually something that could be partitioned into fractions or decimals. So you see, Alexis is planting a garden. She has space that is 5 feet wide, 7 feet long. In feet, we're talking about something we can measure, number line like this. How much area does she have to plant? So one of the ways we could do that is we could draw our picture then, and our picture can be drawn so that it has 7 feet long and 5 feet wide. So I could actually take this, and this is not going to work out perfectly, but we have the right idea. If I were taking this and it's 7 feet long, okay, I'm going to do that a different way. And it's totally unfair because I didn't have to erase, right? All right, more or less, I think I've got 7 now. Do I? That makes sense. And then we're going to, so these are each 1 foot blocks, if you will. And then we're going to do the same thing. We're going to split it to be 5 blocks wide or tall in this case. It's not perfect, but you have the right idea. So this is 7 feet long, 5 feet wide. So 7 times 5 is 35. All right, so this is audience participation time. We have everybody but Wendy here today, I think. So who's Wendy's partner? Okay, so everybody move around for me. Okay, I'm gonna pause this. Move to find your group work partner. All right, so we're going to give examples. I want 3 examples of each. Lexi, go for us. What do you have for repeated addition?
Okay, our math class meets 3 times a week for 5 weeks. How many times do we meet?
Perfect. Yes, Shayla.
We put Susan eats 3 meals a day. After 5 days, how many meals has she eaten?
Okay, you choose 3 times 5. Awesome. Okay, very good. One more for repeated addition. Yes.
Abby reads 4 books a week. After 4 weeks, how many books has she read?
Perfect. Okay, everybody with me on that? We good with repeated addition? Okay. Number 2, array. Yes, Haley.
Molly is playing memory and lays with cards and 6 rows each home. How many memory cards do we have?
Excellent. That's an array, right? Remember you guys played memory before? That would work. Did you have one more you want to do?
Oh, yeah. Okay.
if we put 4 flowers wide and 7 flowers in the garden, 8 flowers per garden.
Excellent, and that's a really good example. It starts to sound like it would be measurement because it's a garden, but it's the flowers in the garden that makes it an array. Make sense? One more example for array.
There was a band in a parade and they marched in 4 rows with 5 people in each row. How many band members were there?
Wonderful. Okay. All right. That means the 3 groups who are not done yet, who've not given me an example, are all going to do area. Beth, you want to start?
Sure. Malachi is building a tower out of Legos that is 8 inches high and 5 inches wide. What is the area of the tower?
That'll work. Very good. Heather?
Lauren's dad is building her a sandbox. He has space that is 7 feet long and 7 feet wide. How much area does he have to build on?
Awesome. All right. Who else has not talked? All right. Go for it, Shannon, or either way.
Sarah plants a garden, she is 8 centimeters by 3 feet. How much area does it have?
Excellent. Okay, everybody have the idea of the differences between these two? Okay, so we're going to stop on this one today, and I want